When a wave moves through a medium like this slinky, it moves the material in that medium, like part of the slinky. Our job here is to look into the movement of material in a longitudinal wave. Now, we're not talking about a transverse wave that goes up and down like this. We're talking about one of these longitudinal waves, and recall how that works. The hand pushes on here and it causes a compression to be, it generates compression. In this picture, that compression is moved from this hand to this point, and there it is. It's a compressed area. And there's one in front of it too, okay? These are called compressions, and a wave is from here to here, isn't it? Of course, the movement of the wave is in this direction as the compressions move. I'm just pointing out this red spot in the medium because we're going to be interested in how that red spot, which is a portion of the metal of the slinky, how it moves when a longitudinal wave comes by. All right, here I've actually drawn a ribbon tied to that spot right there. What's happened again is that the hands come forward, cause a compression, it's moved to this point. And our job now is to see how does that ribbon move, which will represent the movement of the metal in the medium, or the slinky. Here's your video code, ribbon. All right, so when it pushes here and that compression comes by, how's that ribbon going to move? It's going to move forward some, isn't it? Moves that far forward. Now, it's not going to go forever. It's not going to travel down to the end of the slinky because the pulling force back here stops it, doesn't it? So it'll stop, and what will it do next? Well, it'll start to move backward now. We see here it's moved back to where it started. Okay? Does it end right there, do you think? No. Because usually the force involved in the stretching of the spring or the medium has enough force to pull it back to the left. Now the ribbon, which means the metal of the slinky, is now to the left of where it started. And then it'll then come back to where it started. And so what happens is this ribbon moves back and forth, doesn't it? Now it might take 3 or 4 of these moving back and forth for it to stop moving. I'm showing it just one of them here. It might do it 3 or 4 times, and each time it's going to move not as far. The distance here to the right will be less. But eventually, it'll stop moving and come back to where it started. So the question is, how does the material of the slinky or the medium, how does it move? Well, here's how it moves. It moves forward and back, doesn't it? Back and forth. This ribbon shows it is attached to a piece of the metal of the um, medium, sorry, and that metal of the medium goes forward and back, doesn't it? And right along that center line, doesn't it? It moves parallel to that center line. Now, also, one more thing it moves parallel to is the direction of the wave movement. Now, wave movement is coming this direction, and so the metal of the slinky moves back and forth parallel to that. And on the MCAS, they like to ask about that. The other kind of wave, the transverse waves, there's a perpendicular movement of the material. But with the longitudinal, it is parallel, isn't it? It's parallel to the wave movement and to that center line. Okay, bye.